New technology toolpaths have been steadily introduced into FeatureCAM for 2.5D roughing. These new technology toolpaths have now been extended to work for finishing operations in FeatureCAM 2013 R3. This gives more control and makes for easier programming of two-axis finishing operations. The new toolpaths give a number of benefits, including stop model support, clamp avoidance, and if using the finished bottom in particular, bigger stepovers, continuous spiral, and also high-speed machining options. In this example we have an adapter plate, and we're going to look at some of these finishing operations, with the exception of the stop model support, which is covered in a later video. If we look at the part view, we can see we've got a number of features already pre-created. If I go ahead and just play this as a 3D simulation, you can see we get our part machined like so. And let's go and concentrate on this feature here. So for this top feature, if we want to use our new technology toolpaths, we simply go to the strategy page, and in this case we can choose our new technology for our roughing operation. To turn on our new technology for finishing, we simply check the NT toolpath box, and you'll notice here that we get a choice for our finished bottom as to the type of stepover we're using. Without the new technology, if I go to my finish and preview this toolpath, and just viewing from the top, we can see the shape of the toolpath we get. In particular, note some of these sharp direction changes as we're working our way around the form of the part. Let's go ahead and modify the strategy to use the new technology. Again, if I go back to that finishing operation and preview, we get our toolpath shape like so. So we can modify the way the tool moves in these regions by using some of the new high-speed machining options. In this case we go to the milling tab, and you'll notice you get a number of high-speed machining options, including the maximum tool overload, which will introduce trachoidal moves. We've got the profile corner percentage, which will introduce a rounding to the last profile. And we've also got the smoothing allowance, which will try and smooth out the toolpath as best it can using the raceline technology. In this case, I'm going to change my smoothing allowance. I'm going to add a smoothing allowance of 30%. This will allow my stepover to vary by up to 30%. In this case, I'm hoping to see some more direct or straight line moves as we get to the extremities of the toolpath. Let's preview this finishing operation. And you can see here clearly we've got straight line moves. The tool's taken the most direct route it possibly can before we start to follow the form of the part. This can also be seen down the bottom here as well. Could also introduce trachoidal moves, but in this case we're not going to get any deep, heavy cutting or difficult corners because we've got quite an open part. If we introduce a small amount of overload and preview this toolpath, we get a small amount of trachoidal machining in these tighter corners, but everywhere else is pretty open and less likely to cause overloading anyway. As well as this, if I go to the stepovers area, in this case I can set a large stepover. At the moment the tool we're using is the largest metric tool I have in this case, which is a 25mm end mill. If I go to my stepovers, set this to be a large value, for example 25, apply, preview the toolpath, and you can see in areas where there is the largest stepover region we get a move that tries to clear the material out. If I change the move from a direct to a smooth move and apply, and again preview, you'll notice we get these teardrop shapes appearing in any of these corners where we're trying to clear the material in a large step over. So those are some of the finishing options that we have available to us. I can turn off these two operations and look at the next two. Now, as well as this, we also have the option for collision checking. Now, in this particular instance, you can see at the moment we can't see the clamps and fixtures. That's just simply because they're being hidden onto a different level. So let's turn those on. So here we can see some fixturing holding the block of material down. If I choose to make these my clamps for simulation, if we go back to our original toolpath, and again let's just switch our new technology off, and the milling parameters and step over parameters, I'm just going to make sure I've got the default values set. Let's play the 3D simulation. So here you can see clearly I've machined through the clamps themselves. I'm going to turn on my collision checking. Just to clarify that we do get a collision. So with the previous technology, there wasn't really much we could do about this. We would have to create a boundary or some kind of restriction, maybe a curve to work inside. With the new technology toolpath, however, we can actually indicate that we want to check against particular faces. Once we've selected new technology for both the roughing and the finishing operations, you'll notice that the check surfaces option becomes available, and in this case we're checking against all the clamping faces. Once I've chosen that, I can then go ahead and play a centerline simulation, and in this case you'll notice that the toolpaths avoid those clamping regions. So we introduce the clamp avoidance for roughing operations in 2013 R2. So 2013 R3 also introduces it for finishing operations as well. So here you can see, for example, in this region where the tool has cleared and avoided those clamps. We can re-verify this again with a 3D simulation, just to make sure that we get no gouges or collisions as we simulate the part.